And that's just the tip of the iceberg.
This is the strange world of quantum mechanics, and physicists still argue about what exactly is going on. David Deutsch's answer is almost as strange as the problem.
What's really happening is that the universe we see is only part of physical reality. There are parallel universes, and each particle in our universe has counterparts in many of the parallel universes. And under some conditions, these counterparts affect the particle that we can see. The universes are interfering with each other all the time.
This behavior can be explained by the particles hitting other, hidden particles, ones that belong to hidden universes, in which a different version of events is played out. These parallel universes would allow a time traveler to do whatever she or he wanted.
Suppose time travel is possible. Then you can use quantum theory to work out what would happen if you went into a time machine and travelled back into the past. The answer is that you would come into the past of another universe. And that's really why there's no problem with free will, because in the universe in which you emerge, you're free to do whatever you like, and nothing you do there will affect the universe that you came from.
Imagine a ball gets potted, travels back in time and heads for the pack, threatening its own history in a pool ball version of the grandfather paradox. If there is only one universe, something must prevent it interfering, because we already know that it didn't hit the pack. But in a multiple universe, something else happens. As the time travel occurs, the ball moves between two different games played in two slightly different universes. In one, the ball simply disappears forever, never to be seen again. And in the other, the ball appears from nowhere and disturbs the pack. Because this is not the universe it came from, there is no need for it to fulfill any particular destiny, and neither universe contains a paradox. In fact, the theory implies there is an infinite number of these parallel universes, and that time travel would simply involve skipping from universe to universe to universe. A working time machine would in effect test this extraordinary idea, and if it's correct, then not only does free will exist, the nature of reality itself is very strange indeed.
As far as I'm concerned, the paradoxes that people talk about are only going to be resolved after we build the first time machine. Then we will know whether or not free will enters into it, whether there's multiple universes, or whether the universe is determined. That's going to have to be understood experimentally.
Building a real-time machine will not be easy, but if Mallett is right, then the biggest revolution mankind has ever seen will be upon us, and sooner than you might think.
"20 years ago, it would have been close to professional suicide, but because of the fact that there's an enormous amount of articles, serious research articles in the professional journals about time travel and time machines, it's no longer considered to be part of the backwater. It's considered to be at the forefront of research today. So I'm at the front line rather than being ready to be institutionalized.
Although Einstein correctly worked out that traveling very fast sends you into the future, a further development of the theory should allow travel into the past. And even if it's only the odd particle or two, that would be a massive advance.
If Ron Mallett's experiments turn out as he hopes, then it would immediately put an end to the controversy about whether time travel would ever be practicable. Because although in his machine we're going back in time really only with information or a couple of particles, nevertheless the principle of the thing is what is at stake, and that is what would have been shown to be possible. So although even in that most optimistic case, we shouldn't be expecting practicable time machines to be in the shops anytime soon. We can be confident that one day in the distant future they will be.
So how do you get from being able to leap into the future to being able to tunnel into the past? This is the core of the professor's quest, the journey that started with the death of his father many years ago. The plan is to use intensely powerful rings of laser light to twist time into a loop, an effect expressly predicted by the theories of Albert Einstein.
With a circulating beam of light, you'll create a rotating region of space, as though you were stirring at a cup of coffee. Also, in addition to twisting space, in Einstein's theory, space and time are linked. So you cause a twisting of time as well. So if we think of time, our timeline, as being a line from the past to the present to the future, if I can close that line into a loop, I can go from the past to the present to the future, but we're on a loop. So I can go from the future back into the past. It won't be simple, okay? Real world experiments aren't, but it will be able to be done.
This is the basic form the machine would take. A stack of lasers creating layers of circulating light, around which the predicted loops in time should occur. Explaining how this machine would work is something of a challenge. And in the future, in a museum that charts the history of time travel, perhaps the best way will be to start with some suitably ancient science fiction.
In the old movies, people often suggested one particular way to get to the past. All you have to do is exceed the speed of light. There was this guy called Superman. Superman flew around the Earth at such a speed that he arrived before he left. And all this to save his girlfriend's life. Now, this may be impossible, but as often happens, fiction contains a grain of truth. And if somehow you could travel faster than light, you would travel to the past. And that's the key to Professor Mallett's marvelous idea.
With Albert and Bertrand's help, it's possible to see exactly how Superman saved the day. This time, they each have a light clock to show how time is being altered. And just to show the principle, Bertrand is going to be like Superman and orbit the Earth as fast as he likes. Flying along with Bertrand, we zoom past the stationary Albert once each lap. And here, relativity comes into play. Seen from this moving point of view, it's now the photon in Albert's clock that has to take a longer path to get from one mirror to the other. So even though Albert's not moving, for us, Albert's clock begins to run slow. The faster we fly, the slower Albert's clock ticks. If somehow we could break the speed of light, the clock would not only slow down, it would stop and then actually begin to run backwards. Just as predicted, we would now be traveling into the past. But the makers of Superman didn't get everything right.
You can't go back in time by exceeding the speed of light, because there's a law of physics preventing you from even reaching the speed of light. But that doesn't mean that you can't go back into the past. There's another way.
In building a time machine, this is the ultimate challenge, to discover a way to cheat. Somehow, you have to be like Superman and exceed the speed of light, but without having to break the laws of physics. Luckily, science has known for some time about naturally occurring objects that could be used to produce just the desired effect. What you need is a rotating black hole. A black hole is so dense that a single teaspoonful would weigh much more than the entire Earth. And its gravity is so strong that even empty space has to succumb. It gets dragged around and around like water in a whirlpool. Here, on the edge of oblivion, physics is pushed to its absolute limit.